Hey, what do you know today? I'm glad to see that you took time out from your busy workday to check this program out. I'm sure you'll pick up some good information on the Model 150 manual transmission. Information you can make pay off on the job. First, we'll cover the theory of operation, which is pretty simple to understand. We'll look at the 150's power flow and see which components are doing what when the transmission is operating in the various gear ranges. It's important that you be familiar with power flow so that you can quickly diagnose and correct any operational problems with a 150 transmission. We'll also run through the disassembly and reassembly procedures you can use when servicing the 150. While we have the unit disassembled, we will cover some of the potential sources of trouble you should look for. The 150 is used in AMC and Jeep vehicles with a couple of minor design differences between the two applications. Shown here is the 150T, which is used in AMC vehicles. This unit features a side-mounted shift linkage and a longer output shaft, which is enclosed in an extension housing. The unit used in Jeep vehicles, the T150, utilizes a top-mounted shift linkage. Also, this unit features a short main shaft, which is coupled directly to the transfer case rear output shaft. Excluding these minor differences, the 150T and the T150 are identical. In this film, we'll concentrate on the unit used in AMC vehicles. The 150's forward range gears are helical cut and are in constant mesh. As we'll see shortly, the forward gears never change positions. They're simply locked to the output shaft when engaged. The reverse gears are spherical cut and aren't in constant mesh. As you can see here, there are two synchronizer assemblies used in the 150. Let's look at the individual components. Shown here is the clutch shaft and gear unit, which passes the drive power from the clutch disc to the transmission. Note that the end of the clutch shaft is hollow and contains roller bearings. This allows the clutch shaft to be coupled to the output shaft, which is shown here. The components that ride on the output shaft are the second and third gear synchronizer, the second gear, the first gear, the first and reverse sliding sleeve, which is also the first gear synchronizer, the rear bearing, and the speedometer gear. Remember that the end of the output shaft couples to the clutch shaft to form one horizontal assembly within the case. Shown here are the counter shaft gear and the reverse idler gear. Note that in this illustration, a portion of the reverse idler gear has been cut away to reveal a hidden portion of the counter shaft gear. This photo provides a better view of the hidden portion of the counter shaft gear. This hidden portion meshes with the reverse idler gear at all times. It is also in constant mesh with the first gear, which rides on the output shaft. Let's see what happens inside the case with the transmission in the various ranges. Here, the transmission is in the neutral range. The clutch gear passes the power to the counter shaft gear, which turns the first and second gears and the reverse idler gear. The first and second gears aren't locked to the output shaft, so they spin freely. The reverse idler also spins freely because it isn't meshed with the first and reverse sliding sleeve. Before we shift into first gear, let's take a minute to look at the two synchronizers, the components that facilitate smooth shifts into the forward gears. Shown here is the first gear synchronizer. The components that make up this synchronizer are the brass blocking ring, front insert spring, the first and reverse sleeve and gear, a retaining snap ring for the hub, 3 inserts, and the hub itself. The second and third gear synchronizer looks pretty much the same. The big difference is that this synchronizer utilizes 2 blocking rings, 1 for each gear that it controls. The key to the synchronizer assemblies is shown here. Each gear has a tapered surface that fits into a female tapered surface on the blocking ring. It's this design that allows the synchronizer to speed up or slow down the freely rotating components as is necessary to lock a spinning gear to the shaft. When the transmission is in the neutral range, the countershaft gear turns the first gear, and the tapered surface of the first gear simply spins against its female counterpart in the blocking ring. The blocking ring and synchronizer are splined to the output shaft, which does not rotate when the transmission is in neutral. Now the driver has disengaged the clutch and begun his shift into first gear. The first pressure he exerts on the shift lever begins the synchronization process shown here. The shift fork nudges the sleeve forward, and the teeth on the blocking ring mesh with the teeth on the inside of the sleeve. This activity pushes the blocking ring forward, and the tapered surfaces develop friction. Now the shift has been completed. The sleeve is moved forward and meshed with the teeth on the gear. The gear is now locked to the output shaft. When the driver engages the clutch, the drive power will follow this path. The clutch gear transmits the power to the countershaft gear. The hidden portion of the countershaft gear drives the first gear, which is locked to the output shaft via the synchronizer assembly. This is how the power is routed after the transmission has been shifted into second gear. The second and third gear synchronizer sleeve has been moved rearward, and the second gear is locked to the output shaft. The countershaft gear passes the power to the second gear, which transmits the power to the output shaft via the synchronizer. When third gear is engaged, the sleeve moves forward and locks the clutch gear and shaft to the output shaft. The other gears continue to rotate, but they don't transmit any power because they aren't locked to the output shaft. And here's reverse. The first and reverse sleeve and gear is moved rearward until the gear meshes with the reverse idler gear. Because the reverse idler gear is positioned between the countershaft gear and the reverse gear, the output shaft's direction of rotation is reversed. In the bench chart that accompanies this program, you'll find a service diagnosis chart that will help you pinpoint problem sources in the 150. This chart also contains all of the disassembly and reassembly steps that we'll cover in this film. In some instances, the service diagnosis chart will suggest that you inspect and repair the shift linkage assembly. In this film, we won't be covering shift linkage service, so be sure to refer to the AMC or Jeep Technical Service Manual for complete shift linkage service procedures. The diagnosis chart might direct you to the clutch. As you know, many transmissions have been needlessly disassembled when the problem was in the clutch. So use the hints provided by the diagnosis chart, whether it suggests a simple clutch adjustment as shown here, or a clutch housing runout check. If the top of the housing is out of alignment with the bottom, the transmission might shift hard or emit a noise. If this is the case, shims must be installed between the clutch housing and the engine. So be sure to perform any clutch service procedures suggested by the chart. The AMC and Jeep technical service manuals contain detailed instructions for all clutch service procedures. Here's a very important procedure you should be familiar with. On Jeep vehicles, some manual transmissions, including the T150, share lubricant with the transfer case. For this reason, you should always check the oil level in both the transmission and the transfer case. Check the technical service manual for capacities. Also refer to any applicable diagnosis and repair bulletins. Whenever you add or replace transmission lubricant, be sure to use only SAE 90-weight gear lubricant. In many cases, you'll have to disassemble the 150, inspect the components, and then reassemble the unit. I have one minor problem here, though. You see, there are times when it's advantageous to be my size, but I don't think this job is going to be one of them. I think I better get some help. Hey, Fred, need some easy helper time?
Sure, Mike. I owe you one for the other day when you helped me with that behind-the-dash electrical job.
Okay. The first step is to remove the top cover. If your unit is a Jeep 150T, the shifter assembly will come off with the top. Then remove the long gear shift detent spring. You can either tip the case a bit or use a magnet to remove the upper detent plug from its bore. Remove the extension housing. Use snap ring pliers to remove the speedometer drive gear retaining ring. When you remove the speedometer drive gear, be careful that you don't lose this little lock ball that holds the gear to the shaft. Remove the rear bearing retaining rings. As you can see, Fred, there's a large ring between the bearing and the case, and a small one behind the bearing. Remove the fill plug located in the side of the case. With the plug removed, you can use a hammer and punch to remove the countershaft roll pin. Now remove the rear bearing.
For this step, you'll need this special bearing tool. It sure makes this step easy. Hey, Mike, grab that Allen wrench. Remove the set screws from both of the shift forks.
Now remove the first reverse, shift fork, and rail. To remove the center detent plug, use a magnet or just tip the case a little and let the plug fall out.
Here's an important point. Before the second third gear shift rail can be removed, it must be rotated 90 degrees so that it can clear the detents.
I'll tell you, Fred, you'd be pounding on that rascal all day long if you forgot to rotate it.
Yep.
Now, move up to the front of the case and remove the front bearing cap. Remove the clutch shaft assembly, which includes the front bearing, clutch gear, and blocking ring. The output shaft assembly can be removed from the case at this point. To remove the countershaft gear, first insert the special loading tool shown here in the front case bore. Then tap lightly on the tool to drive the countershaft out the rear of the case. Then lift the countershaft gear from the case.
The nice thing about the loading tool is that you won't find yourself playing pickup sticks with the bearings. With the tool in place, they won't fall out of the countershaft bore. Tap the idler gear shaft out the rear of the case. Then remove the idler gear.
When you remove the countershaft and idler gears, be sure to remove their thrust washers. Set them aside so they don't get lost. Remove both shift fork shafts. Be sure to check their O-rings to see if they're worn. To dismantle the output shaft assembly, remove this retaining ring. With the unit completely disassembled, clean and inspect all of the components. The service diagnosis chart will probably give you some solid clues as to what to look for. Here are some common conditions you should look for when you're inspecting the case. This illustration also appears in your bent chart, so that you can use it as a reference when you're working on a 150 transmission. If you find any of these conditions, replace the case. Here are some conditions you should look for on the gear and synchronizer assemblies. This illustration also appears in your bench chart. Possible countershaft gear and idler gear conditions are also contained in your bench chart. And here are some conditions to check for on the clutch and output shaft assemblies. Remember, if you find any faulty components anywhere in the transmission, replace them now while you've got the unit torn down. To reassemble a transmission, begin by installing the output shaft components on the shaft in the proper order.
There are some good pointers on this step in the AMC and Jeep technical service manuals. Be sure to use them here. Install the retaining snap ring on the output shaft, then measure the end play. Mike, what does the service manual recommend if we're out of spec here?
Replace the thrust washers and all the snap rings on the output shaft. If the shift fork shaft O-rings are worn or cut, be sure to replace them. Then, install the shafts in the case. Coat the 4 thrust washers with petroleum jelly or grease and position them in the case. Be sure that the locating tabs are engaged in the locating slots in the case. Coat the idler gear shaft and bushings with transmission lubricant. Install the idler gear and the idler shaft.
Be sure to align and seat the shaft roll pin in its counterbore in the rear of the case. Measure the idler gear end play by inserting a feeler gauge between the thrust washer and the gear. What does the manual recommend if we're out of spec?
If the end play exceeds the spec shown here, remove the idler gear and replace the thrust washers. Coat the countershaft gear needle bearing bores with petroleum jelly, then install 25 bearings at each end of the gear. Coat the 2 retainers and install 1 at each end of the shaft.
Then install the gear and shaft in the case. As you can see here, the shaft will drive the loading tool out the front of the case. Measure the countershaft gear end play by inserting a feeler gauge between the front thrust washer and the countershaft gear.
If the end play exceeds the spec shown here, remove the countershaft gear and replace the thrust washers.
Install the output shaft assembly in the case. Then, with the second third gear sleeve in its rearward or second gear position, install the shift fork in its groove. Be sure that the set screw hole is facing up. Insert the second third gear shift rail. Move the rail inward until the detent plug engages the first notch on the shift rail, which is the second gear position. Reinstall the shift fork set screw. Next, drop the center detent plug into place and move the second third gear synchronizer into its neutral position. Move the first reverse gear synchronizer into its forward position and position the shift fork. Install the shift rail and the shift fork set screw. Finally, place the first reverse gear synchronizer in its neutral position. Coat the clutch shaft roller bearing bore with petroleum jelly and install the 15 roller bearings. Be sure to use petroleum jelly here. Chassis grease could clog the lubrication passages. Then coat the blocking ring surface of the clutch shaft with transmission lubricant. Install the blocking ring on the clutch shaft. Support the output shaft assembly while you install the clutch shaft. At this point, coat the shift rail expansion plug with sealer and reinstall it in the case. Apply a thin layer of sealer to the front bearing cap gasket and position the gasket on the case. Be sure that the cutout in the gasket is aligned with this oil return hole in the case. Here's an easy one to forget. Remove the front bearing cap seal and use the installer tool shown here to install a new seal. Make sure that the oil return slot in the cap is in alignment with the oil return hole in the case. Then torque the cap bolts to the correct value.
Install the large locating snap ring on the rear bearing and install the bearing on the shaft. Seat the bearing using this special tool. Install the bearing retaining snap ring. Install the speedometer drive gear lock ball and then the gear and the retaining ring.
Align the counter shaft roll pin holes and install the roll pin.
Now remove the extension housing oil seal and use the tool shown here to install a new seal. Replace the extension housing gasket. Coat the bolts with sealer and torque each bolt to the correct value. Install the upper detent plug and spring in the case bore.
Here's an important step. Pour 3 pints of transmission lubricant over the gears. Do this with the transmission in the various gear ranges so you can be sure that the transmission is functioning properly. Now we're ready to button her up. Install a new top cover gasket, then torque the top cover bolts to the correct torque value.
Well, thanks much, big guy. We couldn't have done it without you.
Anytime, Mike. Glad to be of assistance.
Well, that's about it. At this point, the shift linkage can be installed and the transmission can go back into the vehicle. As we've seen in this program, the 150 manual transmission is pretty straightforward, both in terms of theory of operation and service requirements. When you're working on a 150 transmission, be sure to refer to these convenient reference sources. The bench chart that accompanies this film contains all the procedures we've seen today. And your AMC and Jeep technical service manuals are always your most comprehensive sources of information on any component used on our vehicles.